Um, okay, so I'm Willian Molinari. I'm also known by this weird nickname called Potix. Potix. I have no idea how to pronounce that correctly, and I think you can do that as well. So we will talk about how to write a simple game in Rust. Um, and the initial idea for this presentation was to do a live coding session, but I was not able to do the live coding session in 45 minutes, so I decided to build slides for that. So hope it is good enough. So let's start with a disclaimer. So the first thing is that I speak very fast. You probably noticed that already. So you have to get used to it. I tried to improve, but I could not do that. And the other disclaimer is that I'm not a professional game programmer. Yeah. I usually work with web, and I do games for fun. I really like doing games, so that's why I'm talking about Rust here. Rust and games. If you want to see a talk about from a professional game programmer, I would recommend this one. It's by Catherine West. She's the lead programmer for Chucklefish, and they are doing games in Rust, seriously, indie game development. And in this talk, she was talking about ECS development, is entity component system, and data-oriented design. So yeah, that's it if you want to check, and we will get back to this presentation afterward as well. Oh, that's it. So I work for Doist. So for those who don't know Doist, Doist is the company behind those two products. It's Todoist, that is around since 2007. It's a productivity app. Who here knows Todoist? Oh, that's great. We have a lot of people that knows Todoist, so that's really cool. I used Todoist since 2007, and I decided to join the company last year. So I'm pretty happy to be working for them. I really like the product, and I like how the company do business. So it's a great productivity app, so I really recommend you to try it out if you didn't do that already. And I'll be here if you want to talk about Todoist afterwards. And we also have this product called Twist that is focused on mindful communication. So it's a messaging app focused on mindful communication. If you're working remotely or if you have multiple time zones on your team, this will be a great app for you. So you should probably try it out. I really like it. Okay, and that's it for Doist. Let's talk about communities. I'm one of the organizers of GuruSP, the São Paulo Ruby users group. So if you like Rust, join us. We have just access gurusp.org, and there are some information there. We are doing meetups, local meetups since 2008, so almost 10 years. It will be 10 years next month. So I'm really proud of it. And I'm also organizing the Rust SP. So if you want to talk about Rust, it's kind of the same thing, but for Rust. So we are doing local meetups. We did one this month. So that's it. Hope to see you there. And I'm also one of the co-organizers for Rust LATAM. So it's Rust, the biggest conference in Latin America of Rust. It will happen in Montevideo 2019. It will be March 29 and 30. It's not so far from us, from Brazil, to go there. So if you want to go to an international conference, this is a good opportunity. And we are actually looking for sponsors. So if your company wants to sponsor Rust LATAM, please talk to me after this talk. Okay, so let's talk about Rust and games. So we have to start with why. We should always start with why. So why are we talking about Rust and games here? I said I'm not a professional game programmer. So why did I decide to talk about Rust? Every time I try to learn some new concepts or some new language, I decide to pick game development for that. Just simple games, like, for example, Snake games is okay. So what we are doing here is to build a Snake game. So I hope that you find Rust cool enough and games good enough to develop that, to try it out and improve your skills. I did some games in the past in C++, Ruby, and some in JavaScript and HTML5. All of them are open source if you want to check the GitHub, and all are not completed. It's just hobby. So this is a demo I did. It's open source if you want to check it out. And I try to do talks about what I did afterwards. So I did that in JavaScript, Python, and Ruby. All of them were live coding sessions, just to show people how cool it is to write a game, like to see things moving on the screen and so on. So yeah, it's really cool, and that's what we are trying to do here, but without the live coding, because we don't have enough time for that. So let's go to the actual implementation. So there is a website called Are We Game Yet? That it shows how is Rust to game development. So it shows some libraries and some games already made with Rust. So I just went to this website and picked this one. It is the GGEZ, the Good Games Easily. It is based on the Love Game Framework. If you don't know the Love Game Framework, it is built on Lua, and then they just decide to kind of rebuild the same with the same idea, but with the Rust seal of approval. So we will use this library here, and to start the game development, we will just run cargo new snake game GGEZ. Who here used Rust in the past? Okay, that's actually good, because I'll kind of try to introduce Rust by doing games. So yeah. Okay, so the cargo new, I'll show some code. I did that in the past here. So we have, this is the structure that cargo news brings to you. But if we look into find here, I did some trials on in the past, the complete 1, 2, 3, 4, 5, 6. And yeah, I will try to. I have some steps here, and then we'll go step by step. But what the cargo new gives to you is this structure. So it's a cargo 2ML and an SRC with a main. So yeah, SRC main. It's the main file where everything we're going to work. Okay. And on our cargo 2ML file, we have basically this structure. So it's the name of the maintainer, version, authors, and the dependencies. In this case, we just have the GGEZ dependency, and we will just run a cargo build, and it will bring all the dependencies and compile your game for you. In the main RS, it will be just one print ln, and it will print in the screen. That's it. Okay, so this is I know this is kind of hard to read because there's a lot of code there. So, but this brings the window for you. So it is the simplest code to build the window by using constants and so on. But so we will break this into 3 different pieces so we can look into it. So the first piece, I hope it is okay to see there. And then we are just, well, let's talk about the game. I don't know if you had one of these in the past. I had one. It's kind of weird because it says that it has 999 games in one, but it's just 20 games and it's really being repeated until 999. Yeah, okay, I played one of these in the past, and one of the games there was a snake game. So this is what we are trying to build here. So looking into these constants, we have the pixel size that is 20 by 20. So we are just trying to mimic that big pixel there. And we have the sizing pixels, that is the size, the vertical size and the horizontal size, okay? That's what we are doing here. And we have the screen size, and the screen size is just mapping 20 multiplied by 20, it will be 400, so it will be the actual size, 400 by 400, okay? That's what we are doing here. And then we are building our game. So we have a struct that is an empty struct, and then we are implementing the game, the methods for this struct. So this is how it works in Rust. You have a struct with all its members, and then you have an implementation of the methods for this struct. So it's separated, so you can easily see what is member and what is implementation. So that's what we are doing here. And then we are implementing the event handler trait. So this is a trait. Think like that trait is kind of an interface, but on steroids. So there's a lot of good things of a trait, but it looks like an interface. So I want to, this is a good time to show how I usually do things in Rust. Every time I start, I usually run this command. It's a rust app doc --std. It will bring the Rust standard library documentation for me, so you can easily search for, I don't know, what is an option here, and it will bring to you, and you just click it, and it is local, so it's quite useful. And other thing I usually do is run the cargo doc --" open, so it will do the same, but by building the documentation for my current code. So we have, for example, the documentation for the library here, local, without internet. So that's really cool. And I'm doing that because I want to show let me show something else. There are no things here. It's empty because we are doing everything in the main file. Don't do that. We are just doing because, because it's a 45-minute presentation. But if you want to do a game, you will probably split that into files and so on. But if you want to see the actual documentation here, I'll just do cargo rust doc --" document private items. Don't worry too much about that. It's just to show how it is. If we refresh that, so we already have the documentation for our structs, constraints, and functions here, kind of for free. Okay, so it's easy to use the documentation. So it's a first-class citizen in the Rust environment. Okay, so we already have the documentation here. What I want to show you is that, yeah, that's not so good. Just a second. let's just remove this thing here. And then that's it. Okay, so what I want to see here, to show here, is the event handler. So we can just come to our documentation. Hey, what is an event handler? And just click here. This is the actual documentation. So you can see that it has 2 required methods. This is common in game development. You usually have an update method where you update your coordinates, you update your physics, and whatever you have to update there. And the draw, where you actually draw to the screen. For example, in our case, we will draw a small rectangle there. Okay, that's what we are doing. And there are some methods provided here, but that we are not going into details here. Okay, so the documentation is really useful. And another good thing here is this OK. Rust, just like Ruby, it returns the last statement. So you don't have to actually type return. If you don't use a semicolon there, it will just return what you type in the last line. Okay, that's it. And this is the third part where we have the main function. So what we are doing there is just building a context, building the window, using the default values, subscribing to overscribing. Yeah, changing the title, and then we are changing the dimensions as well, and building it. And then in the event run, we are running the game. And if we check the event run as well, just to show you, look for run, for example, and it will bring the event run. So this is important to see. I hope it is easy to see here. If you're not seeing, please let me know. So it's important to understand how the syntax is here. So what is the run? It is a public function run. And there is a type here. So it is expecting context and this type has to implement the event handler trait. Okay, this is how you read this documentation, and that's exactly what we are doing here. So we have the event handler implemented for a game, and we are passing our game there. Okay, that's how there's no magic here. And another good thing is the set background color. So if we look to the documentation again to set background color, oh no, I think that. I mean, oh no, that's it. Okay, so if you look for set background color, it expects a color, and then we are passing a tuple of 3 integers. Why? Why is it? Because Rust is a strong typed language, and why is it kind of using tuples instead of the actual color? And then we have this into here, and what this into is doing, it is converting the color. If we click on the color, we can see that it implements the from trait. So Rust automatically does that for you. So when you call into, it will convert your tuple into a proper color. So you don't have to write a lot of code to do that. So this is really cool because you know that when you have a strong typed language, you usually have to have a lot of code there to kind of build objects and build types and so on. So Rust tries to help you with that. So those 3 numbers there are RGB, red, green, blue, from 0 to 255. So in our case, we have a black background here, okay? So that's what we are doing. And then that's the window there. So if we run here, make bootstrap, I'm just using the make file here. So I will not screw it up copying things. So if we run cargo run here, we should have soon our window, okay? So I will be running the code so you can see the results. Where's the presentation? Oh yeah, it's here. I have no idea why it's here. Okay, so let's implement entities. And then let's get back to the code. We had this, it's kind of transparent there, but we had the pixel size and size in pixels, and now we are implementing the initial state for the snake and the initial state for the fruit, okay? So let's remember we have the snake game, and then we have the snake pursuing the fruit, and when it gets the fruit, it grows. That's it, that's the game. So we have the initial position for the snake and for the fruit, and we have some constants there to avoid typing a lot of numbers because just to build colors. And then let's implement in our game. So we add the fruit, and we add the snake to the game. And then on the new, we instantiate the new snake and game, okay? Nothing fancy here. And on the event handler that we implemented, we will just call draw and snake, the fruit draw and the snake draw. So we could do that in a smart way, kind of having an array and calling all the components, but we just have 2 entities. So this is good enough for this implementation. And we have the snake update as well. Okay, so that's what we are doing. We are clearing the screen, asking to draw the fruit and the snake, and then presenting everything at once, okay, for proper performance reason. But the interesting part is this question mark here. When you're developing in Rust, you see this question mark, and hey, what's that? I have no idea what's that. And then let's get. I don't know about you, but I usually search on Google. But when you search on Google a question mark, you will not get a lot of returns. What we can do is go to the documentation, the standard library, and just type the question mark, and it will say, hey, are you looking for standard try? Yeah, that's exactly what I'm looking for. And then you click on that, and it shows what it actually is, and it is a macro. It's a Rust macro. Don't worry about this weird syntax. We're not going into it, but I want to show what it is doing behind the scenes. So it's a pattern matching. So we have a pattern matching, so it will deal with the error for you, because it will return a result, and then it can be an OK or an error. If it's an OK, we will just return the value inside the OK. And if it's an error, we will just propagate the error to the top. Okay, that's what we are doing here. And I don't know if you use other language. For example, Go, you have to write, I don't know, if R different than new every time, and this is kind of boring. So Rust is trying to help you with this kind of settings here. Okay, it's not just Go, but Go is an example here. Okay, so this is really great in my opinion, the question mark operator. And then we are implementing the direction, because we have to control the direction of the snake, the position, and the new. And there is a new by direction there, kind of omitted there, but we will talk about it afterwards. So what is this position? If you remember the Cartesian plan, that the mathematics kind of boring things you learned at school. So that's what we're implementing here. We have an X and a Y here. So let's imagine that we have -3 for a Y and -3 for X and 2 for Y. And this will be mapped to the game. So, okay, that's what we are doing here. And then we have a lot of code here. I'll not go into the details, but we are implementing the snake. So this is some methods for the snake. We are going to details soon. And then we are making it plot on the same coordinates, and I'll explain it better for the fruit because the front is better here. So what we are doing here, we are building a rectangle, so it's a strong typed language, so we are building a rectangle with the position X and Y. Let's think about the Cartesian plan again. So we have -3 for X, 2 for Y, and we are building a rectangle of 20 by 20. That's what we defined in the beginning, okay? That's what we are doing here. And we are using red, if you can see it here, we are using red for the constant, okay? And it will be materialized in the game, okay? So I can show it running. Again, make second, I hope it is, cargo run. Oh no. This is like coding, kinda. Okay, that's it. So we have our two entities there, and that's it, okay. Oh no, I have no idea. I'm kind of lost in the windows here. Okay, so let's refactor that to a trait. So you can see that we have the construct for the rectangle here and the construct here. Okay, so let's refactor that and create our own trait, implement our own trait here. So what we are doing, we are implementing from position for graphics hacked. Let's kind of change this implementation for convert. So we convert from position to graphics hacked. So every time it's expecting a graphics hacked and it receives a position, Rust can do the job of converting it for you. So we just copy and pasted the code there. And then our code just, it's better now. We are just using this self into and self position into. So if you remember, this structure is a snake head and the snake position. So we are just passing the position to there and it will be converted, okay? So this is amazing for Rust, at least in my opinion. I really like that the language provides this kind of construct for us. And it should be a huge win, right? But no, not so close. Yeah, it was close, but not enough. So what's happening here is that is how you start programming in Rust. When you see your first cannot move out of borrowed content. I don't know if you tried Rust in the past, but yeah, it was really hard for me to understand what was happening here. So I decided to try to explain it. I don't know if I can do that, but I'll try. Let's fight the borrow checker. This is the borrow checker fight. If you heard about that in the past with Rust, people usually fight the borrow checker. This is the part where you're fighting the borrow checker. So what's happening here? Every time we are implementing that, thinking about object-oriented programming. So we have our, in this case, our snake object, and then on the snake object, we are implementing the draw, okay? So you can see there that we have this ampersand here. So what we are doing, we are kind of borrowing our whole struct to the draw method. So it will be borrowed, and when it finishes, it will get back the ownership to the other function, okay? So, but inside this function, we are using this self again. So we are kind of trying to double borrow. And the compiler say, hey, you can't double borrow, man. You have to do things differently. And that's it. Because of it's hard to explain, I tried to build one code from scratch. I just did a cargo new and started building it again. So this is just an example. We have some bootstrap code here just to make it look like the other game. And then I implemented this my drop here. So if you see the my drop, we don't have the ampersand there. So what's going to happen here? Rust will move the data to this function. So when it finishes, it will just free the data. Okay, it's not borrowed. It's just moving the whole data there. And then when you try to do that, the compiler say, hey, you're trying to use afterwards, because we are trying to use it here. We use the method, and then we are trying to use the game position, but the game doesn't exist anymore because it was freed, okay? So that's why we are using borrowing on that old slide here. That's what we are using the ampersand, okay? So this is what is happening here, and I mentioned in the Catherine West presentation. She told me at RosConf that I should not do that, but instead of just fixing that, I decided to show you what problems it causes when you use this kind of code here. So okay, I should watch the Catherine West presentation and understand why I should do, for example, entity component system. But how can we solve this problem here? And the best way to solve it is to add a copy and clone here. So it was a good thing to show how the derive works here. With the derive, you can implement traits to your own type. So that's how it works, okay? So we can show it in the code here. Or not, maybe, yeah, we have it here. So if we make second here, and then cargo run, this is the error we were seeing there. They cannot move out of borrowed content. And then if we check the position here, we just have the partial equal. Let's implement the copy and clone here. Copy and clone. And cargo run somewhere here. And it should work. Yeah, it works. Okay, so we have our window here. So what Rust is doing here is think that it can't borrow it again, but it knows that it can be cloned. So it is just cloning for you, and everything works. But keep in mind that your memory is being cloned. So depending on the size of the thing you're doing, you have more memory being used there. For our case, it's just 2 entities. It's okay. Yeah, that's it. Okay, so that's what we have. I just showed you. So let's deal with input handling. Okay, so currently we have our game here. And I can't do anything. I'm just clicking on the arrows here, and it's not doing anything. So let's implement the input handling. So we had our event handler for game trait implemented, and then we have to look into the GGEZ to find what we have to implement here. So if we look to the documentation and we look for, I don't know, key, for example, there is a key down event. It may be very handy. So we find the key down event. And I'm a good programmer, so I just copy and paste. And it's here on the slide, so it was kind of made up. Yeah, so I already did that. So we have the key down event there. And we are just checking the key code, checking if it's an escape. And if it is an escape, we just close the game, okay? I just implemented a game exit there. And that's it. And the new bidirection that I didn't show before, we were going to implement that. So what we are doing here is just adding the acceleration to this variable, and then we are doing a pattern matching there through X and Y. And then if the direction is going up, we are just decreasing the Y. If it's going down, we are increasing the Y. If it's going left, we are decreasing the X. If it's going right, increasing the X, okay? It's not that difficult. And then there is a parenthesis here. Use constants, okay? Instead of just saying acceleration is equal to 74. I don't know why. So it's a default acceleration instead of 74. So this is not just for games. Do it for every software. It will help you in the future, or the future, employee. Okay, so and the update, it's kind of small here, but what we are doing, we are generating a new head every time. So in every update, we are generating a new head and removing the old one. So it's kind of something like that. We have the window here, we have the head, and what we are doing, we are generating a new head and assigning it to the struct. Generate a new head and assigning it to the struct. And if you can see here, we are also passing the direction. So what's going to happen is that if we change the direction, we will create the square in a different place and remove the old one, okay? So that's what it's doing here, okay? That's how the animation works. And we can see it in the next version that is, I have no idea, make fourth, I hope. Cargo, run. And then we wait a little bit. Okay, so it's a little bit fast, if you can see that. Okay, we are expecting, oh yeah, a slow thing, but so let's deal with the FPS here. Where is it? It's here. So let's deal with the FPS. And GGEZ already provides methods to that, so you don't have to deal with, you know, counting frames and so on. So there is this construct called check update time. So it's quite easy to find in the documentation as well. So I don't know, if you look for time, it will be here, check update time. So what it's doing here is just checking to use the number of frames you mentioned. So in this case, I am using default FPS there, and default FPS is just 8 in this case because it's really slow. And again, we are using constant here. It's a constant problem, pun intended. Okay, so let me show how it works after we do that. Make fifth. Oh no, fifth. Oh no. Okay, and we run cargo again, and then you wait a little bit, and that's it. Okay, it's running in a decent FPS. Okay, so let's control the snake. Currently, it's just going, by itself. So what we are going to do to control the snake, we will implement the direction. And then in the direction, we will implement the from key code. So what we're doing here is just receiving a key code and transforming that into a direction that we already know what it is, okay? But in this case, we are using this construct here. It's an option. So Rust doesn't have the concept of new. So you can't kind of create an initialized variable. So in this case, you can have, for example, option that means none means nothing. It's not new. It's just a type that means nothing, okay? And you can have some that is a type with a type inside of it. So what we are doing here, we are just matching and returning an option that can be some with the type of direction and none in case we don't find anything, okay? So that's what we are doing here. And then on our key down event, what we are doing, we are just calling this code that we just implemented. And then we are using a new construct here called IfLet. So what IfLet does, instead of doing a match and then matching types and so on, it will check if it returns some. In this case, it will assign the return of some to the direction, and you can use the direction inside. Okay, in my opinion, it's a great construct. So that's it. So we are assigning the direction to the snake direction. So it should be working, right? Because we are passing the direction here. So let's run it again. Make 6. Oh no. Yeah, that's it. Cargo run. And we should be able to control the snake now. And that's it. I'm actually controlling it here. It's not a video, I promise. Okay. Yeah. So let's handle the window bounds. And when I mean window bounds, let me show you. When we wait a little bit, it's going to the infinity and beyond here. So if we click left here and wait a little bit, and then the player is coming back, and then it appears again in the screen, and it's going nowhere again. So we have to deal with that, okay? There's no point of just seeing the player in a place you can see. So let's deal with that. There's a clever implementation by this girl, Fusha, on Twitter. I think this term HN, her nickname on GitHub. So she had this clever implemented module sign and with some bounds here. And it's kind of complicated. It's really clever, but it's complicated. It's also worth noting that my code is highly inspired by her. So yeah, thank you for doing that. And then I'm implementing the dump version of it that is just 2 ifs. So we are doing an if minus less than 0. So what we are doing here is this thing. Hey, we have a head here, and we are going to the right, and then if we reach the right, we are just going back to the left. and that's it, okay? That's what the if is doing, so. Okay, that's it. Let's try it out. I have no idea which one is the, okay, make 7, thank you. Cargo run. And then we wait a little bit. And then, yeah, that's it. Okay, it works, right? Okay. Let's get back to the presentation. And let's add a body for the snake. We are saying that it is a snake, but it's just the head. So it's kind of weird, you know, like just the head of the snake walking on the screen. So let's fix that. So what we are doing here, we already know how to deal with the head, right? We are moving the head in the screen and so on, but we don't have a body. So what we are doing, we are creating a vector of position. So in fact, it's a vector of heads, which is kind of weird again. But so we kind of have a body of heads, but don't think about it too much. Okay, so we have the vector here. This is one of the constructs for vec. So we are creating, where is it? Okay, yeah, we are creating a vector of positions, okay? This is how you construct that. And we are pushing a new position there. So we have a body of 1, so it's 1 head and 1 body. And what we are, this is a good construct as well. Instead of just writing body, colon, and body, you can just use body because Rust is smart enough to do that for you. So this is really good in my opinion as well. So, and then we are on the update, we are just inserting in the beginning of the vector and removing from the end, okay? That's what we are doing. We are just cycling the body every time. And then, as we already know how to draw the head, we are just using the same construct here and drawing the body, okay? In this thing here, we are actually dereferencing the position, so we will be able to use into, because I don't know if you remember that, but we implemented from position and not from the reference of position, and that's the thing. So you can implement for the reference of position, or you can just the reference because it's safe in this case, okay? Okay, let me show it working or not working. Make a diff and cargo run. Come on, okay. Okay, so we finally have 1 snake, and this is good. It's not doing anything, but yeah, we already have it. Okay, let's handle collision then. And to handle collision, what we are doing here, we are creating some states there. It's the self-collision and native fruit. We are not going into too much detail here. But what we are doing, we now have a if, and in case the if doesn't match, we remove the part of the tail of the snake. In case it matches, we keep it there and just change the state, okay? So it will keep growing. And there's an interesting part here. Why we can't compare 2 structs? Because I don't know if you work with C, but you can't just compare structs. You have to compare in a way. And in this case, we are just saying that it implements the partial equal trait. So Rust already knows how to compare that because we are using simple types here. So this is good as well. And then we can actually check that as well. Oh, cargo run again. Yeah. So if we reach the fruit, we are growing. Okay. That's it. But now we have a cheat code. If we just let it run, it will keep growing. We have to fix that. Okay, so what we can do is regenerate the fruit. And for that, we have to use a new crate. So we will implement the fruit regenerate there. So every time we find this state, the 8th fruit, we will call the regenerate. Okay. And for that, we will use this new crate here. It's called rand. So what we do, we add rand to the 2ml and then run cargo build, and it will build, download the dependencies and build it for you. And then we add the extern crate at the beginning of the file. This will change in the new Rust, but well, for now we have to use it. And then we use this rand RNG because we will have to use this type. And then we implement the regenerate. I'll not go into the details on how the rand crate works, but we are just using a random from a thread here, and doing a random from 0 to the size in pixels. So in this case, it's 0 from 420. Okay. So we are just positioning randomly in the vertical and horizontal X and Y there. Okay, but I mentioned this use rand RNG, and you can see I can see any RNG here. And why is that? This was difficult for me because the RNG is here, but it's not explicit in the code, okay? But you have to use it. This is something that I don't like, but it took me some time to understand what was happening here, so that's what I'm talking here. Okay, so let's try it again. Make temps and cargo. So let's compile. So when we reach the fruit, we are actually regenerating it, okay? Okay, stop playing. Okay, so every time now we have to deal with the self-collision. So if we collide with ourselves, we have to kind of game over, or in this case, we'll just reset the snake, so we'll not have to open the game again because I'm lazy. So let's reset the snake. So what we are doing here, we have the self-collision state, and when we reach the self-collision state, we will call the snake reset. So we will be implementing two different methods here. The first one is the reset. So this is a different construct of vac. So we can use this vac, position, and nil, for example, or we can just use this macro because Rust wants to help you instead of letting you type a lot of code. So you just use this macro and creates a new body. So that's what we are doing. We are creating a new body with just one entity, okay? And the self-collision, what we are doing is just looping through the whole body and seeing if and checking if the head and the body are in the same position. That's what we are doing. So what we are doing here, we are checking for the self-collision, so it will return a Boolean. And then if it returns a Boolean, we are changing the state. And then if we reach this state, we will call the reset. Okay. And let's see. Oh no. Make 11th and cargo run. So if we are here growing, happy, as a happy snake can be. And then we touch ourselves, and then we become true again. There are some bugs here. I don't know if I should show that. But yeah, if I can go throughout the snake. For example, if I hit left here, I'm going, it's kind of weird. But I decided to not fix that, so it's kind of an exercise for you if you want to fix that. Okay, so we have another bug here, and I think I have enough time to show it. Let me show if let me see if the presentation. Yes, yeah, we actually have our game, right? So it's working. We have a kind of game over, and we are growing, and we can have some fun. You can send your parents, and they can play the snake game and so on. So the goal of this presentation is to show you how cool it is to build a game with Rust. You're not a professional game developer just because you watched this presentation. But I hope you got some interest in how Rust is cool to develop games and how you can learn new things by developing games. That's what I'm doing for months or maybe years now. So that's it. And I'll probably have time to show what is happening with the one bug, at least one bug. We have time for that, right? I hope so. Okay, so let's run it. And if you press back, you see that it is weird, right? Okay, let me press down. So it's not acting good. And what is happening here is that we have the snake here, and then we got back to just one, and we add the body, but we are adding the body in front of it instead of back. So we have to add it here, okay? So that's what we are kind of weird there. And to implement that, we can just change our new bidirection. It looks like a hack, but that's okay. It's just in one file, so it's a hack anyway. So what we are doing there, we are implementing the reverse there. So we added a reverse Boolean, and then if the reverse is true, we are just multiplying by minus one, and that's great, right? Okay, so I actually have the 12th here, and cargo run. Come on, okay. And that it seems better. Okay, so we have a smooth snake here, or kind of. And that's it. I think that's everything I have to show. And if you want to fix bugs on this game, please let me know. I just left the code here on the presentation, or not. Yes, it's here. So my context is there. I'm POTX everywhere. Yeah, most of the places. So and this is the link for the codes. if you want to, to write it down. And that's it. I'll be here if you want to talk, and if you have any questions about Rust, about community in São Paulo, about Rust Latam, and about the game, I'll be here and we can talk. So that's it. Thank you.